Being recognized as a golden crop of the country, oil palm has led Malaysia to a second ranked in the export of oil palm worth of $9.7 billion in 2017. With the production of palm oil in Malaysia also ranked second in the same year, totaling 21 million metric tons. As of 2019, 5.9 million hectares of land in Malaysia has been planted with oil palms and 46.9% of the land was in the peninsular Malaysia. Sabah and Sarawak were almost equal in their land share for oil palms with 26.9% and 26.1%, respectively. Currently, there are three major bagworm species that are recognized as the most significant pest affecting oil plantation, namely Metisa plana, Pteroma pendula, and Matasina corbeti. From 1990s until present, bagworm outbreaks have been reported to be more severe, in which the oil palm yield had seriously affected by the infestation due to delayed and incorrect control strategies. Throughout an outbreak, the bagworm larvae devoured an enormous amount of photosynthetic leaf areas of oil palm trees, thus affecting the productivity of both number and size of fruit bunches. When the bagworm population reaches the economic threshold or when there is an explosion of pests in the field, control measures using chemical insecticides are the main choice. Biological control approaches have always been highlighted on this research in playing a major roles in pest and diseases management. Recent studies have shown that biological control can work as an alternative to chemical control. Today, pest control management has successfully manipulated living things including microbes as biological agent to suppress the pest outbreak. Entomopathogenic fungi such as Ecosaria fumisorosea is naturally occurring fungi with the capability to infect and kill a wide range of insect pests including several species of chewing and sucking herbivores. These fungi are nearly target-specific and eco-friendly as compared to broad-spectrum synthetic pesticides. Faculty of Agriculture is dedicated to produce myco-insecticide for controlling bagworm population in oil palm plantation. Mechanism of infection by entomopathogenic fungus on insect with disperses conidia on insect cuticle, then spore germinates and penetrates into insect cuticle. Fungus will grow through body and killing insect within 4 to 14 days. Process of invention. Each sterilized flask was added with 100 ml Zapac Dox broth and yeast extract media inoculated with Ecosaria fumisorosea mycelial plug. Then were shake on electrical shaker at room temperature for 120 hours at 150 rpm. Suspended submerged fungal propagules were filtered using enhanced vacuum pump filtration in Buchner funnel. Filtered fungal propagules were scraped off form filter paper and were then be stored in refrigerator at plus or minus 2 degrees Celsius before formulation process. To produce mass production of fungal propagules, bioreactor was used in this study. Bioassay results and field trial. Pre- and post-census of Metisa plana population. In this study, the effectiveness of the insecticides was determined by comparing the number of M. plana before and after treatment application. The larvae were counted prior to the treatment. Post-treatment census was conducted at 1, 7, 14, 21, 28, 45, and 60 days after treatment, dead. The census was carried out in total of 10 palms in each treatment plot. The study revealed that fumisorosea wettable powder and commercial pesticide successful at reducing the population of M. plana. In addition, all of those were able to reduce the population below the ETL of 10 larvae per frond as early as 45 days after treatment application. The effect of insecticides remained up to 60 days. Fumisorosea recorded with the best reduction of M. plana population compared to other treatments that recorded with variation of population change. Study side for side effect of fumisorosea formulations on E. camerunicus. The study was conducted at University Putra Malaysia small oil palm plantation located in Serdang, Selangor. The average age of oil palm was 4 to 5 years old and the height varied within 4 to 5 meters. The area was selected due to reachability of the oil palm pollen even with supporting tools. The area consisted with a high number of anthesis male inflorescences that were needed for the experimental use purposes. The trend of Ecosaria an increase in population a day after treatment application. However, the population started to decrease on 3 DAT and increase again after 7 DAT. There was no significant difference on the mean population of weevil before and after the treatment application. Advantages of the product. Our biopesticide is formulated as wettable powder. Our biopesticide has ability to increase the active ingredient activities. Low cost as it does not need to use expensive technology or tools. Biopesticide formulation consists of Ecosaria fumicida as the active ingredient, surfactant, and carrier/filler. Formulation gives good dispersion and suspension to give a homogeneous mixture in the spray solution. Formulation is able to maintain the viability of the conidia. The intended user: oil palm company, oil palm industries. Its marketability and potential for commercialization. Ecosaria is in process for licensing with SNH Tech Venture SDN, PhD. The approximate cost of Ecosaria production is 500 grams per RM100. In conclusion, stable formulation can be developed following the current results and findings. These will lead to prove the other alternative to controlling bagworm population in oil palm plantation. Impact to environment. Safe to mammals, biodegradable, no harm to oil palm pollinator and beneficial insects. Ecosaria, the green bioinsecticide.